Section 2.8 is about solving absolute value equations. Absolute value equations are in the family of linear equations. They're very similar. They look the same. However, they have the absolute value bars around them, which you guys recognize here in my notes right here. Now, I'd pause the video and copy this stuff down. It's going to be very important. Some things that you need to know about absolute value equations. First of all, letter A. Remember that absolute value means how far the stuff inside, and maybe I should put the absolute value bars right there, how far the stuff inside the absolute value bars is away from zero. Hopefully you learned that from in prior math classes. Letter B. The answer to an absolute value problem is always positive. Always. Unless there's a negative sign on the outside of the absolute value bars, like I'm writing down here in the little corner. If there's a negative sign there, that of course would change the answer back to negative. But otherwise, if it looks just like the absolute value bars, if it looks just like this, then the answer is always positive. Letter C. The absolute value symbol in math was created to guarantee positive answers to real-life problems, problems that require positive answers, such as distance problems. You don't hear of negative distance. It doesn't make sense to say I'm negative 4 miles away from something. Distance is always positive. Therefore, mathematically, they always use the absolute value symbol to represent such types of applications. If you need to pause this, please do. I'm going to move ahead one slide. Letter D. There are always two answers to any absolute value equation. Two. Make sure you make note of that. There are two answers. There is the positive answer and the negative answer. Pause the video if you need to copy that down, but there are always two answers. Now, I'm going to do an example problem for you to demonstrate that there are two answers. Let's look at this. The absolute value of x is equal to 1. What I want to know is what number can go in for x so that if you take the absolute value of it, the answer is 1. Well, I hope you know I could put the number 1 in there because the absolute value of 1 is equal to 1. Or I could put negative 1 in there because the absolute value of negative 1 is also equal to 1. Both of these numbers are 1 unit away from 0. Therefore, if you notice what I did is I took what is on the inside and I wrote it down and I wrote it equal to the positive answer here, and I took what is on the inside and wrote it down, and then I took the negative answer. So I have x is equal to 1, which is the positive answer to the problem, or x is equal to negative 1, which would represent the negative answer. And that is where you solve, or how you would solve, absolute value equations, because you need to write two statements. This one and this one. Now, if you need to pause the video, please do, but otherwise I'm going to skip ahead. All right. I have example number 2, which I'm going to do with you. It says the absolute value of x plus 8 is equal to 5. Now, if you do what we just talked about in the prior video, you take the stuff that's on the inside and set it equal to the positive answer, or you take the stuff that's on the inside and make it equal to the negative answer. When you solve both of these equations, you will come up with the two solutions. And obviously, I'm going to minus 8 to both sides. So here I get x is equal to negative 3. And here I'm going to minus 8 to both sides. And I get x is equal to negative 13. Now let's double check that. Let's say I put negative 3 in there. Well, we know negative 3 plus 8 is equal to 5. And the absolute value of 5 is 5. So that answer checks. Now, what if I decide to put negative 13 in there? Well, negative 13 plus 8 is negative 5, but the absolute value bars change that back to positive 5. So both answers check, and that is how you solve an absolute value equation. Now, I would like you to pause the video, and I would like you to do example 3 on your own, following what I just demonstrated for you. All right. If you solve this problem correctly, the first thing you did is you broke it up into two equations. 2x minus 6, which is on the inside, equals the positive answer 10, or 2x minus 6 equals the negative 10. Now you just solve both equations like you have in the past. On the left side, the first one, we add 6 to both sides, and you get 2x equals 16. And if you divide by 2, I think we all know x equals 8. Over here, I add 6 to both sides, and I get 2x equals negative 4. And if I divide by 2, I get x should be negative 2. Now, double check. Let's take a look. 2x minus 6 is equal to 10. Let's say I put 8 in here. We know 2 times 8 is 16, minus 6 is 10, and absolute value of 10 is 10, so that checks. How about 2x minus 6 equal to 10 if I put in negative 2? If I times those two together, that's negative 4 minus 6, which equals negative 10, and the absolute value of that is equal to positive 10. So again, both answers check. The last problem I want to do for you is going to demonstrate a very, very important rule, which I want you to pause the video and write down at this time. All right, our last rule, when your absolute value equations become more complex, you need to always get rid of all the numbers outside the absolute value before splitting it into two equations. For example, this problem. Here you notice we have an absolute value sign, and there's a bunch of stuff that I'm underlining in green on the outside. The first thing you should do before you solve an absolute value problem is get rid of, and take a look, and then get rid of any stuff that is on the outside of the absolute value. It's kind of like parentheses. So I'm going to do my balance scale line, and again, we do PEMDAS backwards, so I'm going to get rid of the minus 8 first. So I'm going to add 8 to both sides so that those cancel out. I get 2 times the absolute value of 6x is equal to 30. And now I still have the 2 on the outside, so I'm going to divide both sides by 2. And I cancel those out, and I get the absolute value of 6x is equal to 15. Here's where I can now that everything's gone from the outside, now I can break it into two equations. I can write 6x equals positive 15, or 6x equals negative 15. And if I divide both sides by 6, I get x is equal to 2.5 over here. And if I divide by 6 here, I get x is equal to negative 2.5 right there. And those are my two answers. And that is how you handle a situation where you have numbers outside the absolute value symbol before you solve the equation. Get rid of those.